what I'm going to be doing is, see, he put 10 mils of RO water, each one of these centrifuge tubes, and then 5 mils of the silica tungstic acid. And this is setting up for the additive test. So I'm going to be putting 3 mils of our plating solution in here and then centrifuging them for 6 minutes. After that, once they come out, you should be able to read on this tube how much additive you have. You read it on here, and then there's a factor you multiply by to get your result. But before I can do that, I have to filter the plating solution. So I'm going to be pulling it out with this and then running it through this filter. So I'll be running the plating solution through here. So I'm probably going to take about 50 mils out of here. I'll put my filter on. Now carefully hold it on here. Just kind of use your weight to push it through. If you want to get a close up on this, you can see what it filtered through there. You can see the difference after filtering, how clear this is compared to this. Like we said before, there's 10 mils of deionized water, or RO water, in each one of these, and then 5 mils of silica tungstic acid. I'm going to add 3 mils of my filtered plating solution into each one of these tubes. Add 3 mils to that one. Do the same. Mils to that one. So now you actually see it start to gel up. I mean, it starts reacting immediately. So what we do, put a lid on. You just want to mix it up, make sure it's mixed up and not getting stuck towards the top there or in the bottom of the tube. Give it a shake about 2-3 times. Just make sure it's all in solution. That looks good. It's ready to go in the centrifuge. Do the same with this one. So it sticks together up there. But yeah, now it looks better. So now it's ready to go in too. So you centrifuge that for 6 minutes. Alright, so my additive test is done. As you can see, the additive, push down to the bottom and you can get a reading on those. When you get the number, usually we'll take 4 of these and you get a reading off each one. Take the average, and we have a conversion factor that you multiply by to get your number. Stanomatic. You're able to test how thick your coating layer is on, a sample of finished product and your alloy layer. I'm going to be running a sample from the center of the strip. Make sure the top side is facing this way into the machine. It locks into place. Hydrochloric acid here, fill it up, fills up the sample cells. Now it's locked and ready to go. Alright, so the acid's working on the sample right now, and it measures the coulombs, and you're able to get 2 peaks, and that's going to tell you where your alloy layer is, it's going to tell you where your tin layer is. So I can see a peak here, and a peak here, this is on the top, and I can see a peak here, and should be getting one right there on the bottom. So it'll plot these out and it'll measure each peak, so I'm going to be able to tell how much coating I have and how thick my alloy layer is. So what I'm looking for is probably about a 0.5 on the top, 0.1 on the bottom. So it just finished. I got a .053 and a .01. So those are pretty right on the money. Acid drains down into the machine. Don't want to touch that, so we got magnet here, and you can see how that acid works on the sample. Eats right through that tin and alloy layer. Okay, so to run an antioxidant on our spectrophotometer here, basically what I'll do is I'll use that same filtered solution, add it to our antioxidant bottle, which is 2 mils of our solution to 100 mils of water. I need 2 mils of flux. And that's just mixed with RO water. We're just diluting it. You gotta fill it up to the line for 100 mils first. Now you mix it up. Okay. And this one you can get right away. 5.26 is the flux concentration. Our range is 4 to 8, so it's good to go.